Good morning, good afternoon, or good evening, whenever you're watching this. It's a wonderful day outside. It was a wonderful day, and now you're going to math us. Now, not all math is designed to make your lives miserable, to make things seem more complicated. In fact, a lot of the math that we do as mathematicians or scientists is to simplify a process, not complicate it, if you can believe it or not. In this video, what we're going to do is observe the interchangeability and connectivity of exponential and radical functions or expressions, and we're going to learn how to convert between each form as it is convenient in the problem to do so. So when we look at an exponential function here with a rational exponent, what we're doing here is the rational part refers to the exponent in this format, b over c, and what that really is, when we say a rational exponent, that's just another way of saying a fraction. Okay, so instead of us just saying rational exponent every time, we're going to say a fraction. Now, each part of this fraction or rational exponent is going to have a specific place when we convert this to a radical form. The c is going to be the root in the radical form of the function, and the b is going to be the exponent that goes under the root on the radicand. So when we translate the a, b, and c to a radical function, we can see that the a is the radicand, so whatever the power of the exponent was turns into the radicand. The b becomes the exponent under the root, which is on top of the radicand, right over here. And then the c becomes the index, or whatever your radicand is rooted by. Let's take a look at a couple of examples and transform the exponential function into a radical function to see how this makes more sense. So let's convert each rational exponent to its radical form. So the first thing that we're going to do is we're going to put the power underneath the root. So that 3 is going to go here. And for the other one, 4 over 2/3, we're going to put that under the root as well. Next, what we're going to do is we're going to label the a and the b. When we look at the top over here, the b and the c. The b is going to be the exponent that goes on top of the radicand. So in this case, here's the b, so it'll be to the 1. Now, you don't have to write to the exponent 1, but we're just going to be thorough, and so you can see the process. And then the c is going to be the index or the root, which this 3 is the c. And so our radical form is going to look like this, 3, or cube root of 3. And we can just rewrite it like this without writing the 1, so it's not redundant. Now for this one, this is our b, the 2, and then the 3 is going to be our c. So the 2 is going to go under the root, and then the 3 is going to go here as the index. This, of course, simplifies into the cube root of 16, which we can break down further using prime factorization. That'll be 2 and 8, 2 and then 4, and then 2 and 2. And of course, all of these will go underneath the cube root. So we're going to go 2 times 2 times 2 times 2. And of course, we're only interested in that which occurs in sets of 3 because it's a cube root. So we'll take this batch here, pull it out, and go 2 cube root 2. And this is the radical form of 4 to the 2/3. Let's convert 7 to the power of 5 over 3 to its radical form. So the 7, being the power, is going to go under the root. So I'm going to do that in red. Your 5 is the b, and your 3 is the c. Now remember that the 3 is going to be the index outside over here, and then the 5 is going to be an exponent on the radicand under the root. And we won't simplify this time because it will take some time to simplify, and also it's not asking us to simplify, it's just asking us to convert. Let's do one more, but I want you to pause the video and try this one yourself.